And we're back. And it is COMP392 in the winter 2016 semester. And we are week 2, lesson 2, right? Part 1. I can't believe it's week 2 already. Flew in a flash, right? So we just did this little quiz. And I wanted to ask you some other questions about stuff. One of the things I wanted to ask you about is around TypeScript. I know some people are questioning this stuff. But if I go to play, which is our playground in TypeScript, I did this little example last class on the TypeScript here, the playground, that's what this thing is. And playgrounds are a real popular alternative to using an IDE, some kind of editor, right? And here's an example of this, right? I did class person, right, as an example. I defined a class, and this is not something that, the script isn't something that should be weird for you if you've ever seen this before. And then, you have a private instance variable. So again, we have access modifiers for a variable. This is private. And in this particular case, it's a string variable. And in the constructor, what we're doing is we're passing in a string variable that's a local parameter, only to the constructor function, so in between these two braces. And the class variable, which is underscore name, and again, as a convention, just to mention it again, we're going to use underscore for all of our private and protected variables, right? So we have the same coding style. Okay, that's what I want you guys to establish, right? And to keep a little structure, because we can make JavaScript really stupidly unstructured. Please, I never want to see V, W, X, Y, I, unless you're talking about X and Y coordinates, right? X, Y, right? But otherwise, I want you to make a real variable name so that it's human readable, right? Otherwise, it's really hard to read, right? So notice how this is our person class, and here we did our person function on the JavaScript side, right? One thing to note, and I want to just go over a little tutorial here with you, or the actual handbook. If you look at it on the site itself, we're going to be using a lot of TypeScript throughout this course. Again, this course is not about TypeScript. You learn TypeScript. It's about 3JS and how to use three-dimensional stuff. Do 3JS stuff on the web, right, with web technologies. So let's talk about some basic types again as a review. Basic types of TypeScript are Boolean, right, which is JavaScript. And here's an example of how you declare it. And this is right on the site for you guys to see this. And I'd ask you to take a look at this as this is like you're going to be your Bible when it comes to writing TypeScript. So var, again, the variable keyword, that's what it is done, that's the name of the variable, and then the type, Boolean. And then you're assigning it right away. Remember that if I didn't do this, if I didn't put this in here, if I didn't put this in here, Boolean, TypeScript would automatically do type inference and say, well, is done is probably a Boolean because you're assigning it a value of false. False is the actual value, the literal. That's what it is. So there's two literals you can put in for a Boolean, true and false. And when you assign true or false, then it knows that it's a Boolean, right? Same thing for number. If I assign a number, a numeric literal, 6, 6.1, 7,375 or whatever, as long as you make it numeric, it'll know that height is numeric and it'll be a type number. So that's your second type. String, this is all JavaScript, by the way. Everything I'm talking about here, even though it's TypeScript, these are JavaScript types. They're just, remember, JavaScript is loosely typed. We didn't say JavaScript has no types, right? It's just that they're interpreted, right? That's all they've done. Okay, so string types are kind of weird, eh? Strings are they're actually an object in JavaScript. So keep that in mind when you load up a string like Bob, just like in other languages, it's actually a string of letters, right, or characters. You have B, O, and B, and B would be in the 0th place. It's like an array or a list, right? So you can do things like string.length operations for strings, just like you would in other languages, right? And again, notice how you can use single quotes for your literals, single quotes here, and double quotes. All right, that's totally possible for strings, right? Just a review. Arrays. Notice how this is the type declaration here, but there's two different ways. And I'll be honest with you, this is the better way, the second way. I'll tell you why. Because if I declare an array, right, and if I use the array keyword, I can specify in these less than and greater than, these angle brackets here, the type, right? So I can do something like this. Var list array of number is equal to a new array of number. I can do that. And it'd be an open array. You wouldn't have to specify how big. Here, what you're doing is you're using an initializer, right? The initializer, the square bracket 1, 2, 3, is initializing the array, this existing array, with some values. However, just keep in mind that in JavaScript and in TypeScript, arrays are not just arrays, they're array lists, right? So you can treat them as an array and as a list, and they have both properties, okay? And that's good, that's really powerful actually, because there are some languages that arrays are immutable, right? Not so in JavaScript. In JavaScript, they're not immutable. You can, once you establish a value, that thing has a value, and you can change the value, but like I said, you can modify the length of the array to it, you can pop from it, you can do all those kind of operations in JavaScript, and it's a little bit more flexible than in other languages. Enumerations. Sometimes you want to specify a color value or a day or something like that that makes sense, and we want to use enumerations almost like a pseudo type, like a data type, but not really a data type. An example of this would be this. I'm creating an enumeration called color, right? And in quotations, or in the braces, we're putting in the color types, red, green, and blue, right? And then what I'm saying is I'm declaring a variable of type color. So this is the new type, which is an enumeration. So what's the value of green? Would it be a 1? Would it be a 0? Would it be a 2? What is it? Would it have a value? Huh?
It can be 1, but like in enunciations, it can be anything different.
Does it really matter is the question I have to ask you, right? If I compare, if a number is green, it's green. Do we really care what the value is behind? We may not. That's what I'm saying, right? It's an enumeration. It's a human readable way of doing things. And look at the next example here. Members start at 0, so that's the real value. 0 would be red, unless you otherwise specify. Red is equal to 1 in this particular case. And that means that green is equal to 2. Okay, that's how it goes. So it's not like we haven't seen this kind of stuff before. So if you see an enumeration, that's what those are. And they're very useful because they can set up things like, if we're going to do something like a state machine, which you probably will at some point, you could certainly do things like, the start state, the run state, the idle state, and each one of these, run, idle, and crouch or something like that for a character or an object could be an enumeration if you really wanted it to. And it wouldn't matter. As long as you can compare what you're looking for, you're good to go. So very interesting type. I'm not going to go too much into enums. You guys covered enums in C#, yeah? I'm putting my hand up, right? Some people did and some people didn't, depending on the teacher, right? You covered enums, but then you forgot about them because you just kind of glanced at them, but you never really used them. Type any. This is like, honestly, it's like telling TypeScript to go you-know-what itself, right? If you use type any, it's like, hey, TypeScript, get out of here, right? It's one of those. It's like, don't use TypeScript if you use type any. Type any is like a fallback. If you don't know the type of an object somehow and you want to fix it, use type any because it could be anything, right? It'll take whatever, right? How about if you don't know the type, or if you want to make a very flexible function, any is probably a good way of doing it. I don't recommend it. Try and stay with those types: number, Boolean, string. Something like that would be the way to go. Okay, you don't want to say type any unless you absolutely have to because you don't know what else goes. Okay, that's the way to do it. Void, that's a type. I don't return anything. It's really kind of nothing, right? And what we want to do is, it's like any, but void, what it does is we want to declare the return type of a function. We can return string, number, Boolean, whatever. We can also return nothing or void. And we want to try and do this as much as possible so that it gives us good tooling. So if I create a function and I don't expect anything back and yet I return something, it's going to error. I want it to give me an error because then I'm doing something weird, right, that I didn't figure out. And the other way around, if I put in here string or number instead of void, I want it to give me an error if I forgot to have the return, right? So that's why we do that tooling. So that's really kind of cool. Interfaces. Interfaces are kind of like the most misunderstood pieces of object-oriented programming. Okay, first of all, what's an interface? If you were going to give it in your own words, right? What's an interface? How would you describe an interface in any language? What is it for? Anybody? Huh? Keep going. Yes. What else? Let's try and.
It's a class that doesn't have its methods declared or working.
basically it's used if you have a certain set of classes and you have common methods.
Yeah.
And you want to be able to add new methods to those classes. You use an interface that will help add all those methods.
Okay.
Basically, all in one. So both are.
You could use it for that. You could use it for that in it's kind of a long way of saying, think about it this way. I like to say interfaces are almost like a handshake or a contract, right? I want to make a contract that my class is going to take the shape. That's why it's called structural subtyping up here, like you see it. The shape of the interface. The interface is going to define what's the class is going to look like before I have a class. Right? So I'm saying, hey, let's make a contract. All of our classes that use this interface have this particular property and maybe this particular method. Right? That's what it is. It's a contract. And what it does is it forces programmers to use certain properties and certain methods, right, along when they inherit that interface, right, into their classes. It allows you, we don't have multiple inheritance in JavaScript, right, or in TypeScript. But what this allows us to do is use an interface alongside with a class, a class to inherit from. Here's something else to note. If we ever look at patterns in JavaScript, one of the things they always tell us to do across all object-oriented programming is do inheritance last. Why would I want to do inheritance last, right? I mean, it's easy for us to think of, well, here's a class and I want to inherit from the class and add more methods and properties to this class or whatever. But why would I not want to do that instead of, and there's other things you can do. Well, what's the bad thing about doing that? Especially if I had multiple layers, like nested inheritance. So I have like a superclass, and then I have a subclass. Then that class becomes a superclass to another subclass. Why is that bad? Why could that be bad? It could be good too. But why could it be really bad? Anybody? Well, what if I make a change to my superclass that breaks all my subclasses all the way down the line, right? It's really, there's a dependency chain, if you will. It's called, inheritance chaining, if you will. So the chains, the links are really strong between your superclass and your subclass. So if I make any change to one, it changes the other, and we may not want that to happen. So it's far better for us to use something called composition. Who remembers what composition is from C#, Java? We've talked about it a couple of times, different languages. Yes, I'll go to you about next.
It's inheriting from one superclass to multiple classes and take methods from both.
Methods for you. That's like you're almost saying it's using multiple inheritance.
It's like pseudo-multiple inheritance.
What's your answer?
Yeah, I think it's when you if you want to inherit from different classes, you just create objects of each class.
That's the answer. That's the answer.
Just use these methods. So it's kind of like multiple objects in one.
So example, I have a ball class, right? A ball class, I want to use the ball object inside another class. Okay, how about this? The better example is I'm using a deck of cards, the deck of cards example, right? I have the card class. The card class, right, is using another object from the suits class, right? A suit. And maybe a face class for faces, right? You have two different objects. It's inheriting into the card class. The card class is an object that's being inherited into the deck class, right? But it's not a direct inheritance. It's different objects that we create with other classes. We compose our class with different objects from other classes. That's the way we want to go, more than a direct line of inheritance. That's bad. There's too much of a dependency chain, right? So I'm bringing that up because as we get through this stuff that we're talking about, you'll see that there can be really a lot of problems in creating inheritance, right? Like direct inheritance. And this is kind of an advanced class. So I want to try and bring that into play. And what I present to you is probably the best way to do things is, and by the way, there's many design patterns out there. Actually, there's 23 officially. I don't know if you know that. There's 23 official design patterns in programming, object-oriented programming, right? And one of them is the observer pattern, right? The observer pattern. And there's other ones called the state machine pattern, and there's others, right? So take a look at, if you're interested in the design patterns out there, take a look at programming design patterns, 23 programming design patterns. They're original design patterns that successful object-oriented programmers came up with to help us go around some problems that we have when we use inheritance directly. Okay, this is just my aside. Okay, so we talked about interfaces as being a contract. So let's take a look at this. So we have our interface. Here's our function, print label, right? Where we have a label object. And notice that we can also declare objects like this. When I use a curly brace in JavaScript, it's an object. And the object itself has a label in it, a label property, which is of type string, right? This is an anonymous object. It's an unnamed object, right? And what we're saying is my labeled object is of type anonymous object that has a property of label. Very complex when I look at this the first time. If you've never seen this notation, you're like, darn, that's ugly, right? But they exist all over the place in JavaScript. So don't be afraid of it. You just have to look at it like this. I always look at the curly braces as an object, right? That's the first thing I want to try and do. So here's an example of this. So var my object is, again, when you see curly braces, it's an object. I have in sequence, separated by commas, right? Two properties here, the size property, which is 10, and the label property, which is of type string, all right? Those two properties that are part of this anonymous object is now my object. I've made an alias, actually, for this anonymous object, right, called my object. Therefore, I could do something like this. My object.size it would be invalid, right? And so it would be my object.label, right? Because my object is equal to, we use the equals operator to assign it to this anonymous object. So we're giving it a name, which is my object. Clear as mud, right? I know. And now we're going to use the print label method. Print label method, what we're going to do is we're going to fire off this method. This is Java, so and a bit of TypeScript, because what we're going to be doing is typing here. But I'm using the print label method, and I'm passing in this anonymous object. Well, guess what it's looking for? It's looking for an object. Print label is looking for an object that has, right? What? A labeled object, which is a string, which is an object type. It's looking for an object type, and that's why you're sending in this my object. Two objects, right? There's the size and the label, right? Well, label, what ends up happening is this recognizes the need for this label because it's the same name, and the size is another property to this object that it didn't care for, it doesn't need, right? So here's something that's easier to look at. Here's my interface, labeled value, right? And when I use my interface labeled value, I need to have the contract that I make with classes that inherit or labeled value is that they all have to have a label property that's a string type, okay? So there's my interface, right? Okay, cool. Well, look, not only can I use my interface, like I said, right, to inherit, but I can also use it as a type. Here's an example of that. My labeled object has a labeled value, which is this interface, just like this, but instead of it being anonymous, it has now a name, right? The labeled value name. It almost looks like an enumeration in some ways as well. They're actually interchangeable if you think about this, right? It's its own new type that I'm declaring. I'm not declaring what it is. I'm just saying that the labeled value has is a object, right? And that it has a property of label inside of it. Okay. I'm bringing this up because interfaces in JavaScript, in C#, in Java are very complex. We're not going to handle this too much, but when you look at this manual, you might be tempted, and you might be, you'll be forgiven to think that using an interface is very straightforward, right? But please be careful. When you see it, doesn't mean you have to use it, right? This is one of those ones you can put aside until you figure out how to use regular TypeScript. I'll move on. Optional properties. This is one that's really cool in TypeScript, which allows you to use, to declare properties of a function as optional, right? And then the notation for that is the quotation mark, or that's what you're using. So you declare a value, like for example, color. That's the variable name. The quotation mark after the variable name says it's optional. You may or may not declare this. Hey, what's the default for a string? If you don't declare a string, if I declare a variable that's a string, but I don't actually assign a value, what's the default value for it? What's in JavaScript? It's JavaScript, right? What is it? Empty string. How about undefined? Is that possible too? Right? So I want you to, we're going to test this out a little bit, because one of the things that really messes up as programmers when it comes to JavaScript is we don't know what the default types are. And then we don't know why we're getting them. Why am I getting an undefined? Why am I getting a null? Why am I getting this, empty quotation stuff? What about the default for a number? You'd like to think it's 0, wouldn't you? Maybe in other languages, right? But this is in other languages. This is JavaScript. Whether it's TypeScript or not, we have to think about the values. We're going to check this out in a second in a real example, right? Here's a function. We have create square, which is a function, and we've declared this a config variable, which is of type square config. Okay, so what am I saying? Square config can have either the color or the width or none, right, defined to it. That's what it means. That config itself has 2 optional values, optional properties. It's a config object. It's not a config type. The type itself is an object type because we have 2 properties that are assigned to it as part of this interface that we were defining, right? And it returns 2 things, right? It's an object. This is how you return multiple values out of a function in JavaScript. You're returning an object, just like you would in other languages, right? So when I return that object, I'm returning an object that has 2 properties, color and an area, right? That's what I'm returning. And that means I have to have down here a return type. If I declare a return that's after the function declaration right here, if I put this colon after the function and I declare something there, I have to have a return value. Otherwise, it will error out. It won't allow you to do that in TypeScript. Okay? JavaScript will let you do whatever you want. JavaScript will let you return gobbledygook. It'll let you return whatever. Doesn't mean it'll work. It'll fail silently. And we don't want our JavaScript to fail silently, especially with 3JS. We're doing 3-dimensional, translations, and something fails silently. This doesn't work. You're like, wait a minute, what happened? And you don't know, right? We don't want that. And we don't want that in Node. You're doing Node.js, and suddenly it fails silently. You don't know why, but your server doesn't work. That doesn't make any sense. You want code hinting, and that's why I'm introducing this stuff to you. All right, so if you notice, new square then, if I'm returning new square has to be, right? It has to be an object. And if it is, look, when we enter this function, we declare a local variable new square, which is an object type, because I'm using curly braces. In curly braces, there's 2 values here, color and area, and it's given us default values. So even if you don't take in values in your config, that's why it's optional, you're still going to return white and an area of 100 as a default, right? That's what it does. Now, if you change the color value, this is what this is doing. It's saying, hey, if I have a value for color, which is an optional, right? If I have a value for it, then take my new square.color, new square, we're using the dot accessor to access the color property inside the new square object, right? Set new square.color equal to config.color. Right, so new square.color, which would normally be white, equal to my config.color that's incoming into my method. If there's a value, same thing with my width. The second if statement says if I have a width, then set it up. Otherwise, take the default values and return them. That's what this is doing. Yes.
So the string
If I put nothing, then this would return false. Right, because you're checking to see if the color value, and this is it. Actually, let me put it this way: it either exists or it doesn't exist. Okay, if it exists, if this incoming config color exists, then this will resolve to true. If it exists, right? If it doesn't exist, so it's truth C false C. It's not really true false. So if this exists, if the width exists, it's been created. In other words, when you set it, it gets created, right? If it's created, then this fires, right? That's what happens. I want you to see that because this is some real powerful stuff when we do optionals. You can write some classes really cool this way by creating optional parameters for your functions. They're tricky, but they give us some flexibility when writing a function. We can write a function that does a lot of things, right? Almost like without having multiple signatures. We can have one signature with a bunch of optionals. Now, keep in mind that the optionals all have to be written in order, right? So if you assign the first one, that's okay, right? If you assign, and if it's written like color and area, you have to do color first and then area. Or you can specify which one you're handling. So for example, if I do something like this, color, the name of the property, and then set the value, right? So an example of that would be here. So I'm setting up the color black, but I don't care about width. Right? I have to specify which property has been set. Otherwise, it'll error out. Okay, you can't just say the first one or the second one. It doesn't know which one's first or second. It's just an object. Okay. So the question mark, very, very powerful. Optionals. It's something that is part of ES6, and it's now part of TypeScript. Okay, I'm not going to get too much into that. Function types, right? I think what I want to say about function types is that there's two ways of writing them, all right? And for this one, I'm gonna revert back to our playground. Let's go to our playground for a second. I want you to try this yourself, all right? So here we are. I'm just gonna erase all this stuff here and just wipe it out. And in our playground, I'm gonna try some functions. There's two ways to write functions in JavaScript for those people who don't know. The first way is like this: var my function, right, is equal to an anonymous function, right? So how do I do that? It's function, and then console.log. This is my function. One way of writing it, and that's totally valid. And if you notice on the right, it's TypeScript, JavaScript. It's exactly the same, and there's no error. If I run this thing, and if I run my function, let's just call my function. So we'll say my function. That's how you call the function down here, right? As an example. And if I click run, and when I go to run the function, and if I look at the inspector, right, and if I go to console, this is my function runs, right? That's what you would expect. Okay, function, my function. So this is one way of writing it, and this is called, this is almost like we're creating an anonymous function. So this piece here is the anonymous function piece, right? And this piece here is my alias. I'm creating an alias, almost like a pointer, C++ for C++ people, right? It's a pointer to the memory location of this function. That's what it is. Now, you might think, Tom, why are you going into such details? It's just a bloody function. Because that's what it really is. It's a pointer. So people misunderstand and think that it's like a function, right? But truly, this is an anonymous function that appears and disappears in memory. Okay? Okay, here's something that you can do in TypeScript. And I'm sorry to kill you like this, okay? TypeScript has something called arrow functions, which you're going to see a lot in ES6. So instead of putting the function keyword, we can do something like this. Take the function away, right? And then you can do something like this, the fat arrow function that looks like this. That's valid. That's new. You might have not seen that before. And it resolves to this. Look, it didn't change. So this is a way of saying that my function is equal to this empty function. That's what it is. And what I want to do is it points to, the pointer is to this, the body of this function. That's what it is. That's why this pointer, that's what this actually is, a pointer, right? This is valid TypeScript, and it's very nice, actually. One thing that fat arrow functions do for us, just as a reference for you guys, is maintain the context of this, wherever they're called. That's really super important. They're like lambda functions, lambdas, or generics in other languages, right? So, and by the way, lambdas exist in Python. They exist in, now they finally exist in Java and C#, right? Fat arrow functions, or arrow functions is what they're called. And these functions you'll see more and more in ES6, right? I'm not going to use too much of this because I know sometimes if you haven't seen this kind of syntax, it may be confusing. But just in case you come across some TypeScript that looks like this, it's a fat arrow function. All right, here's the other way that it can be written. Eh? This is the nice way that I like, that you'll see me writing all the time. Function, right? Which is my, my function, right? And then some kind of return value, void, and then it's one of those, right? And then console.log, this is my function. That way it's very, very understandable. But look what it does, right? TypeScript and JavaScript the same, right? It doesn't convert this to the other way. One thing to note, this format is slower functionality in terms of running than this format, which is the other format that I talked about. So if I was going to go back the other way, and if you were going to type it this way, var, you have to use the var keyword, var my function, right, is equal to function, right? This methodology is faster, with a semicolon there, is faster than the other method. Just a note. Less clear for some, right? But faster. Callback functions. Whenever we do callback functions for event handling, you'll see them done a lot like this. Just FYI. Okay. So some callback functions. Here's something else. If I have a function, right, as an example called my function, or an object, as an example, that's pointing to a document object. So let's say I have a document object called canvas. I have a canvas on my document, right? And I want to make a reference to it. Who knows how do I make a reference to that in JavaScript? I want to make a reference to an HTML element in JavaScript. How do I do that? What's the syntax? Or document.getElement by whatever, right? ID, class name, it could be a bunch of different ways of getting it. So what does that mean? It means that if in my HTML I have an element that has an ID of my ID, right, and I want to link to it, then I would do something like this: var my variable, right, is equal to documents, right, dot get element by ID. And I've noticed how all the get element by ID is what we want to look at. And then in brackets, the name of the element. Notice how it gives us some code hinting. A string that's the element name. So an example is like my element, whatever the element's name is, right? Whatever we name it, whatever the ID is, or element IDs, we should probably put in there, element ID, whatever the element ID is, right? So what is this really doing? What this is doing is it's saying this: take my HTML element, whatever it is, and create a binding, a reference from my HTML element in my HTML document and assign it as a pointer to it in my variable. And if I hover over it, notice that my variable now is of type HTML element, right? So if I ever want to make a binding, right? So let's say, for example, element ID is actually pointing to a div, right, with an ID of element ID, right? And every time I click on the div, I want it to do something, right? How do I do that in JavaScript? I could do my variable.onClick, but the nicer way to do it is my variable.add event listener, right? And what I want to do here is I want to say the type of event, which is click, and then afterwards, a callback function. Hey, here's that callback function stuff as this. We can make it an anonymous callback function that looks like this function, right, inline, with looks like this. That's the way that we see a lot of it being done, right? And under the click function, I'm just going to make this, I can't move it over, but I can make it a little smaller for you. Let me just make this slightly smaller than what it is. Here's what it looks like. So here's my variable add event listener. It's a click type event. And inside, inline, this is my callback function that's inside this. I'm passing an anonymous function as a second argument, right, to add event listener, right? Add event listener is a method that exists in all in JavaScript by default, right? And then let's say I want to say console.log, right, as an example, you click me, right? Which will actually, every time I click the whatever the element is, I don't have an element that has an element ID of that, but it'll print it out. Now this is what the JavaScript will look like. It's identical. There's no difference, right? My variable, which is of HTML element type, I can actually, explicitly say that HTML element, right? I could say that my element is HTML element type. And if you've seen JavaScript before, all I'm doing is typing here, right? My function is an anonymous function, but I could always use a fat arrow function here as well and do one of these, right? This is the other way to write it. You might see this. This is TypeScript, right? And the more modern way, of course, is to use the on function, right? So I can do the same thing, my variable.on, and notice that there isn't an on, but see how you have on select, on abort, on activate, and a bunch of other on type functions, right? Also, take a look at the type of definition for onSelect. Look what it says here. HTML onSelect. It takes in a value of the event and then returns fat arrow any. Right? You're going to see that a lot. That's why I'm talking about fat arrow functions. So when you look at a declaration, you're like, okay, I understand what that does. All right. So HTML. So you're going to see functions in many different ways, different formats. And that's what I'm saying. The way it looks in JavaScript is messed up. Again, here's what I recommend that you do. All right. If this bothers you, and if we ever do some kind of event listener, just take it out, man. Just take this whole thing out, cut it out, right? Because you can always do this, right? My div clicked. Let's call it. We might call it the my div clicked method, right? Which we don't have yet. And whatever my div is, you can say something like this: function my div click. This is also equivalent to it, right? I'll make it a C, capital C, just to keep it the same thing. My div clicked. And if it bothers you, you could do something like this. You can have console.log. You click my div. Clicked my div. I know it sounds funny. It's good. Keeps you on the ball, right? Keep you on the balls. Go ahead. But anyways, if you notice how this is, my div clicked, right? My div clicked is the callback function. Funny as it is, right? My div clicked is a callback function for this click event, right? And again, if you notice, it's perfectly valid JavaScript on this side. So instead of you including the anonymous function here, right, you can have a callback function that's separate here. Okay, totally valid JavaScript. So I'm going to write it in different ways. Is that a question, or are you just touching? Yes.
What's a better standard practice?
My recommendation to you is you do it this way. That's my recommendation, always. Unless it's a function. This is from a memory saving perspective. If you're running a large application and the function has no value, you're never going to call that function again, right? If you're never going to call that function again, I told you that's why it's faster to write an anonymous inline function, because you're never going to write it again. So you create it and destroy it right away. You don't have to name it. Naming takes extra memory. And if you're writing some kind of web app, every piece of memory or a transaction per transaction counts. Imagine you have thousands of users using your web app, right? So you want to kind of slim it down as much as possible. You want to compress it as much as you can. Okay, so that's one way of writing it. So you're going to see functions. That's why I brought functions up a lot. Let's go back to this learn thing for a second, right? And I'm talking about basic JavaScript here because some of you don't know basic JavaScript very well, right? We talked about that day one, right? So let's take a look at this handbook again. So we're going to go to handbook, and I want to go back to functions, right? Before we go into modules, I want to kind of skip ahead to functions because functions are kind of the bread and butter of what we do in JavaScript. And they show you it right here. Take a look. So again, a named function and an anonymous function. Those are two ways of doing the same thing, right? Again, here's something. I have function scope is always something that freaks people out, eh? Here's var z, right? What's the scope of var z in this context? Global, bad, right? Global equals bad, typically, right? In most languages. In JavaScript, it's very common, right? Global bad. And then we want to add x and y. X and y, are they global or local? I like to think that they are. Yes, global and local. These are good. This is a good way to do it, right? But what you want to try and do is you want to type it like this, right? You want to kind of never want to try and declare a function, even if it's quick and dirty to do it this way. Then you're kind of going around TypeScript. We're using TypeScript to give us some code hinting. Say, Tom, you forgot something, right? If you don't do this, JavaScript will not complain. It's going to fail silently on you, and you're going to get mad. You want to break your computer. That's why we're doing this TypeScript stuff, so you don't break your machine, right? You don't throw it out the window. Okay, so that's what I'm saying. So type, whenever you do a function declaration, type what you're getting in and type what's coming out if there's anything. Even if it's void, type it, put void, right? Don't leave it blank. It's the way we want to do it. It's easy for us to do it. And here's the, again, this is the fat arrow function. You can use the fat arrow return type as well, like right here. So there's both ways of writing it. This way with number, right? We're returning a number, and we're also returning it this way. Both ways are correct. Okay, so enough about functions. Let's talk about classes. I don't want to go too much into functions because it'll confuse you later on, right? For classes, like we saw last week, you need a couple keywords. One, the class keyword, right? Like we do in other languages. In lowercase, some languages have uppercase class. What language is uppercase class? Right? What, and in types in C#, lowercase or uppercase? What is it? Do you remember? I'm sorry. Yeah, it's the other way around, right? All right. So a constructor is a new keyword that doesn't exist in either language. Doesn't exist in Java. Doesn't exist in C#. The constructor function is really, and that's why we call it the constructor function. We'd like to think of it as a constructor method, but because we're in JavaScript and we're not in another language, I want you to call it the constructor function, right? Even though it is a method type, right? And here we have our first method, greet. Notice that it's like a function, but we don't use the function keyword, right? So we don't say function greet ever in a class. We just mentioned what the name of the function is, right? And its return type. And this is a bad example because it doesn't have the return type. You should have a return, and you should have the access modifier. What is the default access modifier in JavaScript? Public, always. If you want to hide stuff, you got to explicitly say private. What about in Java? What's the default access modifier in Java? Sure. How about in C#? What's the default? Is it? Why don't you guys look it up? How about you look one up and you look the other? You look C# up and you look Java up because C# is private, right? Okay. So please keep in mind that whenever I declare a variable, any variable in a class, default in JavaScript, TypeScript, public. This could be bad if you want to do some information hiding, like we do in object-oriented programming. We'd like to make the greeting, unless it's absolutely necessary, private. Private instance variables, public properties. And the only way we can make public properties is getters and setters. I don't see getters and setters here. Is there? Yes, there is. Right? Here's some examples of classical inheritance where you have an animal. We did this last week with the person class, right? And the student, let's say as an example. Class animal, class snake, extends animal. Remember I told you not to do this unless you absolutely have to, because when you inherit, right, now you have an inheritance chain. Something changes, it changes. You really want that to happen, right? So be very careful, especially when you go down multiple levels. Like for example, a special type of snake, like a rattler, right? Rattler would be a subtype of snake. Snake is very generic. You don't know what kind of snake it is. That's almost like an abstract class too, snake, right? Just like human is an abstract type. Human is not it's a biped, right? But human doesn't mean anything, right? So that's more of an abstract type when you think about it from a concept perspective. If you look at it as a business rule, when we write a class, the more specific it is, that should be the class, the actual class we create objects from. If it's really generic and really out there, that's an abstract type of class, right? A class that never gets instantiated, right? Something up on top here. And we want to avoid as much as possible this inheritance chain if we can. Otherwise, what will end up happening is somewhere down the line, I'm going to have to make multiple changes. And especially in a larger application we're talking about, like a big spanning application, those changes can be devastating because you have to go down the line and change all the stuff, all the subclasses all the way down, which would be really bad. All right? Yeah.
Super function, the same way as in Java.
Correct. If you declare an inherited and extends keyword, once you use the extends keyword, you have to have the super keyword if you have a constructor. If you don't have a constructor, you don't have a super, right? What happens with if you don't have a constructor? If you don't declare a constructor but you extend animal, what really happens? You use the default constructor, which is the empty constructor, which is bad. That means you might as well not do it, right? Yes, but typically what we want to try and do is, and I'll answer your question in a second, Joshua. We want to try and put the super as close to the constructor as possible. In this particular case, as you notice, it isn't required. Not like Java. In Java, you can't do this, right? Can't do it. You have to, and even in C#. C# has that colon in the base class, and you have to put it in right away. You're not so in JavaScript. JavaScript, you can separate the superclass declaration. You can pass into this. This is actually calling the super method, the method that's moved as part of the superclass. That's what it's doing. Move is declared up here, and you're calling the super move method down here, right? Okay, but typically, no, you don't have to. Yes. Anything else? Is that the one you wanted to ask?
No. This is a prototype keyword ever common in TypeScript?
No.
It's replaced by
class, the whole class concept, right? Prototypal inheritance or whatever, that's in JavaScript, right? And that's when we convert. So if I was going to go to my playground again, remember the whole thing we did with the playground? That's the only time you'll see prototypes, right? Prototypes are only for JavaScript, and that's vanilla JavaScript, right? They use prototypes, prototype chaining, for them to create their inheritance, right? We don't want to do that because it's easier and better and more visible to do it this way. This makes sense to us. We can read this, human readable, right? Here's private public modifiers. This little handbook is a little bit out of date. It also includes protected. protected for classes that are inheriting from other classes, okay? Successors. This is where we get those, when I want to use these getters and setters, take a look. So I have my private full name. Hey, they use my best practice right here, huh? This is good. So here's my private best practice full name underscore, right? And then what we want to do is, actually, to be honest with you, I use their best practice. I'm just lying. But I use the get keyword plus the name of my of a getter, right? Full name, which is like a method. It's an accessor method. And then, of course, it returns a string. And it's going to use the this keyword to access the private instance variable to do this. Guys and girls, I'd like you to start doing this as soon as we start. Okay, so remember, and you're going to see some areas where you can say, Tom, shouldn't that be a public property? Push me like Stephen pushes me all the time when he sees that opportunity. I'm pointing out Stephen because we had a class last semester and he did it all the time. Tom, that's a public property. Should be public property and private instance variable. It's true. Why? Because it protects. Yeah, you were. But it protects. It protects us from making mistakes, right? We want to have control. Remember, we can put more in here in our method than just this. We can put all kinds of other logic inside our getter and setter that will do some validation for us before we set this property, right? This instance variable. That's what we want to do. It's not just about getting and setting. We can also do some other things in here, and that's why we use getters and setters, or accessors, if you will, for this kind of thing. It is good. It's absolutely good. Yes.
Would you write the getter and setter? If you didn't have any logic for the setter, would it just return default if you left it blank?
If you don't specify it, then again, what ends up happening is it goes back, it reverts to blank, right? So, I mean, if let's say, for example, all I did was write the getter but not the setter, right? That would be a read-only property, just like we would in other languages. There wouldn't be a setter, wouldn't exist, right? Very rare that we would write a setter but not the getter, right? And inside the setter, if you didn't do it properly, like if you put set and then you didn't assign anything in the middle, it would give you an error. You have to be careful how you do it because it'll error out. It'll say it to you, right? Okay, so getters and setters. Static properties are here's another thing that's really weird for people that don't understand what static is. What's static? What does it really do? Okay, all right. Who else wants to? Tell me what a static variable is, because you're sitting there looking at me and you're so nice. Tell me. In your own words. Huh? You're with him, right? How about the guy in red in the back? What's a static variable?
You can use it as a globally but it has initial values.
Okay. All right.
Even the object is not there, but the static variable is in there.
Okay, that's very close to what you need to say. Basically, what you say is, when I declare a static variable, right, I don't need to declare an object in order for me to use that variable as a container, right? My own words, right? So think of it this way. So I want to use the variable, but I don't want to declare an object. I just want to use that variable. So I want to make a static class. If I make a static class, I can use that class, but never instantiate it. I don't have to instantiate it as an object, but I can still use it. Can you guys give me an example of that, right? Main, right? There's an example of that in another language, right? But there's lots of examples where we want to do that. For example, an assets class. If I have an assets class, I may not want to declare a type asset equals the new asset. I don't want to do that, but I want to have access to all my assets, right? Almost like an asset container class. That's what it is. And container class is where we use statics a lot, right? Okay. I don't want to go too crazy about this because I don't want to confuse you too much more than you are. And there's a lot that I'm telling you today. Yes.
So if you put class static grid, would that error out? Or would that just declare grid object?
If I say static class grid, right? Static would be your modifier, right? Yeah, and then so grid, it would be static class, so that I never have to instantiate it. Correct. Right. If I have a method, I can pull from that class. I can use the class's method, almost like as a utility class or a container class, without actually declaring an object. Whew. Okay. One more thing, and then we're going to stop. We'll take a break, and I won't kill your mind more. We did this already. I want to set up a module because I want to split across different files. And actually, the first examples that I gave you, your boilerplate, already does that. It already has a module, right? How do I declare a module, and what are modules? Think about modules as separate files, right? And instead of having one big, long, massive file of JavaScript, I want to break it up, and each class is going to have its own file, right? I want to create this thing to happen, but in order for me to split across files, I need a couple of things. I need the module keyword. So that's the first thing. So this module keyword I need, right? And then I need the export keyword in order for me to export or expose elements inside of my module. These elements could be classes, variables, and functions. So you don't have to put a class in this module. I can simply put variables instead of a module. An example of that would be if I had some kind of configuration file and my variables were constants, because, for example, the screen size, right? I want to make it available in my module, but I don't need to ever instantiate that variable. I just need to access it as a container. It's globally available, but I want it to be encapsulated inside of a namespace. An example would be a namespace config. If I was going to play that out, it would look like this. If I make a module, and I want to call this module config, right? In my config module, right, I want to declare some constants, right? So I use the const keyword for constants. That's the one we use, right? And I want to declare my constant as, I don't know, screen width. Why am I using caps? It's well, final, or it's a convention, right? And my screen width is a number that I kind of assign to 640 pixels, right? This is what it looks like in JavaScript. This is what it looks like in my module. And you know what? Is this accessible outside of this module right now? No, I have to use the export keyword in front of it. If I use the export keyword, now my constant screen width is available outside of this module. And how do I access it? How do I access my screen width constant outside of this module? How do I do it? What is my, how? I could require, but that's require JS. That's common JS. How do I do it with TypeScript? Anyone have an idea? How about over here? What do you think? Girl in green, tell me. Well, how would I do it? How would I access my module in another language if it's a namespace? Using, okay, or I can, sorry, someone said it, config dot. I use the name of the module, dot, accessor, and then the constant, right? Outside of this module, I have to say config dot screen width, right? That's how I access it, because notice how it says here, look at the JavaScript. Config is the actual name of the variable, and then the module, right, is screen width. So config dot screen width is actually right there. Config dot screen width is equal to 640, and that's how I would access it outside of this module, right? How about inside the module? Do I need the config keyword? Nope. Because it's inside the module. Anything inside this module, I can just say screen width, because it's inside these curly braces, right? And here's something else. What's this called? This is actually a some kind of function. I kind of talked about this last time. By the way, I will be testing on this next week. This piece right here that I'm going to show you right now. So what is this called? And I'm going to show you this right now. So it starts like this. I'm going to get rid of it also. This is start from scratch. So it looks like this a lot, because we're talking namespaces. I might as well. It looks like this. So, and then you look at like this. What is this called? There's different names for this. But what does it do? I know, you look at it and you're like, what the hell is that, right? Yep, there's an anonymous function, that's this piece. So you've got partial marks. Sorry? It initializes itself, you mean it calls itself? Okay, so here's this calling part right here, right? All right. Self-executing anonymous function, right? These are very common. This is common. Actually, it's also called an iffy, right? An iffy, right? And the iffy is an immediately, what the hell is it called? It's IIFE, immediately something function expression, immediately invoked a function expression, right? And what it means is without having to call anything that's in here, anything that's in the middle of this function here automatically executes. So if I have a line in here that's console.log, and I put in, here's my iffy, that's how you spell it, right? Immediately invoked function expression, right? Immediately invoked function expression. I'm going to test you on this thing, right? And if I was to run this thing, here's my iffy. Look, it's the same. TypeScript, JavaScript, same. If I run it, right, and if I look at the inspector, notice how if I've done everything correctly, it runs automatically. It actually exposes and it runs. It calls itself right away, right? Why? That's the better question. Why would I use an iffy, an immediately invoked function expression? Why would I bother with that? And actually, you see it in AngularJS if you're taking emerging technologies, COMP392. You're going to see it in COMP392 in emerging technology. You're going to see it in other places in JavaScript. Why? It's also called the closure. Why do I bother doing this? Because anything that's in here, if I declare a variable, right? Variable, my variable, right here in this namespace, right here, and I make this my variable equal to 10, right? What's my variable out here? So my variable, can I even access it? My variable. The answer is no. So it encapsulates my variable and my memory inside the immediately invoked function expression in the iffy. Let's call it an iffy to make it easy, right? It's actually what it's called, nickname, right? Or anonymous self-executing function, right? Huh? Yeah, there's also, that's the other way for it to be called, right? So I can't access my variable because it doesn't exist outside of this namespace. Look, when I hover over it, it even says it, local, right? So this is a common pattern that you're going to see. And so when you see it, don't be afraid of it. Embrace it. Say, I understand why it's there, right? And it's there because we don't want to have global variables ever, right? But I want us to access a module. An example of that would be if I had a module that's inside of this, above this function somewhere like this, right? Here's a module, let's write it together, right? So here's a module, and I'm going to call this module config. And inside my config module, I'm going to export my constant that's called screen width, screen underscore width, right? Now notice what context we're in right now. If I go, my screen width is 640 pixels, right, as an example. Let's do another one more. Export a constant, so my screen height, right? Another good example is 480 pixels. Here's 480 pixels here, right? Can I access, if I say my variable now, right, is equal to, and let's make it realistic, my variable, which is a number, is equal to, how do I access my screen width? Can I do that? Config dot, and look how it comes up, right? Screen width and screen height. So here's my screen width. My variable is equal to config dot screen width. That is totally viable. What if I just wanted to do just screen width in this context? Could I do that? Screen width. And the answer is no, because of the iffy. The immediately invoked function expression creates a closure that doesn't allow anything in. It treats it almost as a separate file, right? Be aware of this, yes.
Yeah, yeah, all variables in the module, if you don't export them.
They're exported. But I can't access it here like this. I have to use my config dot to access them because of my immediately invoked function expression. If I didn't have these here, this wasn't here and this wasn't here, and as long as I'm inside the module, right? If I'm outside the module like this, I need to use config dot. Config dot. Right? And here's something else. If I want an alias, one last thing before we go, right, for break. I want to do a break, 10 minutes to rest your minds, because this is I'm trying to stretch your mind as much as possible and break your head, right, as much as possible, right? Because this is what this stuff does sometimes to people when they look at it the first time. They're like, oh my God, right? If I use the import keyword here like this, import, and if I call this, screen width, if I say is equal to config dot screen width, is that allowed? How come it says first of all, there's an error. It says, an import declaration can only be used in a namespace or module, right? Well, actually, it can be done, right? But be very careful, right? Because we're trying to declare things, we only have one little playground here we're using, right? It doesn't understand what I'm doing, but this is the effect. When I use an import statement to do one of these, to do this, actually what I'm creating is an alias. I can also use the var keyword. If I say var screen width is equal to config.screen width, I'm actually creating a alias, right? So then I could do something like that. I could say var my width, as an example, which is a number, is equal to screen width. That is acceptable because it's an alias, right? And we'll be doing that a lot with 3JS. Why? Because it always goes like this: 3 dot, 3 dot, 3 dot. And why would I keep doing 3 dot over and over again when I can just say the name scene, right? Or, you know, geometry, as an example, instead of 3 dot geometry, right? So be very careful. We can alias the namespace, right, for a particular class or object by using the var or, in many cases, the import keyword, right? And if I hover over it, just tells me screen width is a number, right? Because so is config.screen width. Okay, let's take a break. When we come back, we'll do some 3JS, all right?